All right, all right. So in week 23, part 4, we've got two examples we're going to work through. These are word problems. We'll go step by step, and you can fill your answers in here and below. So here's question number 1. It says height of cloud cover. So there's some clouds up here, and there's a spotlight or whatever. To measure the height of the cloud cover at an airport, a worker shines a spotlight upward at an angle of 75 degrees from the horizontal. So this is crafty, it's just one person. And it sounds like this person sets out the flashlight over here. They measure the angle. They've got their protractor with them, of course. And then they walk 600 meters away and measure the angle of elevation. So again, they are looking at from the ground, or relative to the ground, where is the beam of light hitting the cloud cover. So 600 meters away measures the angle of elevation to the spot of light to be 45 degrees. So they measure this to be 45 degrees. They know this is 600 meters. Find the height of the cloud cover. So go ahead, draw that diagram. You'll see that we have two right triangles. And the tricky thing is that we don't know this distance and we don't know this distance, but together we know that they equal 600 meters. So if you're the diligent student, you're going to put this on pause and try to solve this. So I'll give you that chance right now. Otherwise, I'm going to turn the page and show you what's up. So, because we don't know this distance and we don't know this distance, but we do know that together they equal 600 meters, what we can do is say, all right, let's call this short distance x, in which case this one would be 600 minus x. So we could have called this x and could have called this 600 minus x, and it would work out just as well. So I tried to color code. The right triangle over here is in red, where we can say the tangent of 45 degrees is the opposite over the adjacent, opposite over adjacent. And in blue, the tangent of 75 degrees is opposite over adjacent, so opposite over adjacent. Two equations, two unknowns, we can solve it. We've got those algebra skills. So go ahead and figure out tangent 45 and tangent 75. This one you should just know off the top of your head. Calculator, Desmos, make sure you're in degree mode. And if you do that, we should get something like this. So tangent 45 degrees is 1. Tangent is 75 degrees is 3.7321. Notice how I used a lot of decimal places because this is within the calculation. So now, like, this looked crazy, right? But this is looking like, hey, I might be able to solve that. So my strategy was I can multiply both sides by x, multiply both sides over here by this, so I know that, I'll show you. So I know 600 minus x is equal to h, but h is also equal to 3.7321x. So it's like substituting, or just saying, hey, because this equals this, and this equals this, then this equals this, if that makes any sense. So this equals this, because h equals itself. So this looks totally reasonable. Hey, I've been solving these for years, right? Add x, divide both sides by something. So we added x, divide both sides by that, and we get 126.8. So I solved this out beforehand, obviously. I got 126.8, and I was all congratulating myself, patting myself on the back. And I looked at the diagram, 126.8. I said, all right, 126.8. And I looked at it, and I thought, wait a second, if this is 600, that looks like a lot more than 126.8. So again, with a lot of these questions, you get an answer, you can look at it. Does it make sense? And I thought, that doesn't make sense. So I checked my work, and I realized, hey, I just solved for x, not for the height. So this right here, yeah, that looks like 126.8. So there is a last step where we still need to solve for h. So, using what we have over here, we knew that the tangent of 75 was 3.7321, and we know that's h over what we just solved for, 126.8. So then after solving, we end up with h equals, and I got 473.2, so this 473.2, if our bottom dimension is 600, that looks totally reasonable. Okay, so type of situation where, yeah, it looks like geometry stuff, but we did have to pull in some algebra skills and define one of these distances to be x, and then solve two equations simultaneously. We got that. Okay, second example, so number 2. Looks like this. So we have the tethered cow. A cow is tethered, poor guy, or girl, oh girl, a cow, right, is tethered by a 100-foot rope, so a leash, to the inside corner of an L-shaped building. So here's the building, and is on a leash, she's on a leash to here. As shown in the figure, find the area that the cow can graze. And they kind of give you a hint. I don't like this. If you look at the color of the lawn, it's obvious that, well, the cow is hungry because she grazed all this stuff. So anyway, this is the shape. I'm giving you a hint here. This is the shape of the area that she will be able to graze. So go ahead and see if you can figure that out. You can put this on pause, and in the next slide I will solve it. So we have sectors here where each of them is sort of like, well, no, each of them is exactly a 90-degree angle. So what I have done is, we know that this, the radius, is 100 for this section right here. I'll shade this piece of pizza. Sorry, cow, it's actually just grass, but okay, so it looks like that. And let's look at our formula. The formula for the area of the sector was 1/2 r squared and then times our angle theta. So in this case, it would be 1/2 and our radius squared, and our angle, 90-degree angle, in terms of radians is pi over 2. So if you look at this, what we end up with would be 100 squared, and then a pi, and then an over a 4. So that is just what I wrote out here. When I saw the shape originally, I thought, oh, that's a quarter of a circle. So either way, if you call it quarter of a circle, or if you use our expression, or equation, for the area of a sector, you're going to end up with the same thing. And then all that is left is to figure out, as the cow walks around the building, how much of the leash is left, and so what size quarter circles does she sweep out or subtend. So we have, do you see that as she moves over into this region, there's 50 feet of her leash here, so there's another 50 feet. So this right here is going to be a quarter circle, where the radius is 50. And then for this little section, 20 feet of the 50 feet is taken up, so she now has 30 feet of leash left, and would make this little quarter circle. And here I was using the formula for the area of the sector, same thing. We have our angle in radians as pi over 2. So we have a quarter circle here, radius 30, and quarter circle here, ooh, easy there, quarter circle here, radius 30, and then what happens on the other side? And then what's left over? 60. So 60 feet of leash is taken up, so she's got 40 here, a quarter circle. And then she's, well, yeah, and then she could, rub the leash here, and then it would break, and then she could eat an infinite amount of grass. You lucky cow. So if we add this up, so you could try that. Maybe you already have. Good kid. All right. If you did and you got something like this, pat yourself on the back. That is correct, Amundo.